All right, so here's example one, and the very first thing you should always look for is what trig function are we set to graph. And as you can see, obviously we're dealing with, on this first one, a sine curve. So I already know if I wanted to go off to the side really quick and graph the parent graph, I know that sine starts at 0, goes to 1, back to 0, down to -1, and then back all the way around my circle to 2 pi or 0. So I'm just thinking of my y values on this, starting at 0, going to 1, back to 0, -1, and then back around to 0 yet again. That's how you can think of these graphs very quickly. And remember, all of these are by 90 degrees or pi over 2. So I got 1 pi over 2, 2 pi over 2s, 3 pi over 2, and then 4 pi over 2s, which I just simplified as I said them. Okay? And we like to do it with radians and not degrees, because remember, these also count as real numbers. And so we know that pi is also a little more than 3. So then our x-axis is listed just like our y-axis is. Okay, in real numbers, just like it always has been. So you can see the only difference from that curve right here that we're dealing with, my regular parent graph, we call it, of sine, and what they gave us here was that they did something to the x. If I was to get rid of this, you can see we just have our sine x. So obviously, since it's being done to our angle, our x's, that's what's going to change. And because we had our normal curve up there with our 5 key or critical points, we're 0, pi over 2, pi, 3 pi over 2, and 2 pi. What do we know is going to change on these? Because, again, it was being done to the x-axis. That's what we're focused on, is changing those 5 key points. Nothing else will change. Our amplitude, still a 1. Okay, our period, nothing was multiplied to the x. So since it was just added or subtracted, remember, for x's, since it is being done to the x, we will do the opposite. That means to our 5 key points, we will simply just add pi over 4. And that would then give us our new graph shifted to the right, or positively pi over 4. That's the translation that we're going to be putting on this graph. So instead of starting at 0, I know I'm just going to shift it pi over 4, which is right in the middle. Okay, so you can go through and find all 5 of these key points pretty quickly. It is going to require a little bit of work to get common denominators and things like that. So I'll do that real quick and show you what the 5 points would be. But as long as you have your starting point and you know your ending point, then you would be able to go ahead and graph these. And like I mentioned before, don't worry about drawing it to scale. Just make sure that you put those shifts on properly and label everything. All right, so let me go ahead and show you what you would get if you work these out. And so now you can see my 5 key points, which means all I got to do is plot those, draw it the exact same way as I always have, and I'm done. So if you'd like to just make your tick marks, the normal pi over 2, pi, 3 pi over 2, and 2 pi like we did up here, and then just put the new forms, that's fine too. Or you can just label them with those on it, as I mentioned before, and I'm all good with that. So I'm just going to do it that way and put pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and then I need to go ahead and extend this out a little bit and put my next one, which would have been 9 pi over 4. And because I know that this was a sine curve, I know it starts at what? 0, goes to 1, 0, -1, back to 0, connecting those, giving me my graph, as you can see, just shifted over pi over 4 from every one of my original points. Pretty easy on the first one, just a quick horizontal or phase shift, moving, make sure you note in the right or positive direction, because remember x's are opposite. So for example number 2, you can see there's definitely more stuff going on. I threw in some extra things and I changed it from sine to cosine. So if you're feeling comfortable with this already, you're confident from the previous section, go ahead and pause it here and give this one a try. If you tried it, very good. If not, then let's go ahead and try to see how we would do this one together, and then hopefully you'll get more and more confidence by the end of this lecture. So x plus pi over 3, I know that something is going to change because of that. And remember, since it's adding or subtracting and it's being done to the x, we will do the opposite and shift that left pi over 3. And by that, I'm talking about the original parent function, which in this case happens to be a cosine. Then we're also going to have to do an amplitude change. Instead of it being a normal 1, we will have 4. And notice there's one other piece that we really got to pay attention to, and that is the negative as well. So my amplitude would be 4. My phase or horizontal shift would be left pi over 3. So the way that we denote left is by negative. And then also remember that negative in front that's being multiplied to my cosine is going to give me all of my, since it's not being done to the x, all of my y values, they're going to come out the opposite. So we say that we're going to have a reflection about the x-axis. Okay, so those are the 3 things that we're going to do to our original parent graph of cosine. So some people like to do just small little graphs and do some of those pieces and then give them the final product in the last one. It's totally up to you on how you do that. You can do it that way if you like, or some people even like to do like a small original graph real lightly. So I'll do like a light yellow, start with the 1, 0, -1, 0, 1, and then this right here would be my original cosine graph. And we know that we're going to do a few things. The first thing, we're going to go ahead and take care of our amplitude, which would stretch all of those values to 4. So now I'm going to take every single one of those things and stretch them up, which remember, you don't have to change your graph if you don't want to, but you do have to label it correctly. So if you just want to go 1, 2, 3, 4, and -4, I'm fine with that, as long as you have it labeled. Okay, and then don't necessarily want to do the horizontal shifts because those are the hardest. I always leave these for last. So I'm actually going to flip-flop these. I'm going to do this second and this third. So I'm going to do a reflection about the x-axis, which means now we're going to take this and we're going to lightly change all of these to be their opposite. And again, there I'm talking about the y values. So everything here except the zeros will become the opposite. So all these positive pieces will flip down here and become negative. Flip down here and become negative. And all these negative pieces down here will become positive. So you can see it's a reflection about the x-axis because it's being done to our y values. So that would have been step 2. Let me label these. So now the third and final step would be to actually graph this by shifting everything left pi over 3. Now normally these will not change. You'll start at 0, go to pi over 2, pi, 3 pi over 2, and end at 2 pi for sine and cosine. One full period or circle before it repeats. This time now what we're going to do is shift everything, every single one of these 5 key points left pi over 3. So again, going through this on your own off to the side and getting my new values, you should get something like, and once you have these 1, 2, 3, 4, 5 values, then you know you can plot them and you're done. Just making sure that you still continue with your amplitude and reflections that you already made the change on. Okay, so whether you like to do these parts off to the side, like I mentioned, real small, and then do the final on the big graph, it's all good. Just again, make sure that you have it labeled correctly. So that it's not confusing, I'm going to make that shift off of those original tick marks that I put, which before this actually stood for pi over 2, pi, 3 pi over 2, and 2 pi that I started with. All right, I'm actually going to do the shifts that left pi over 3 so that you can see how it's going to change a little bit. Okay, and that would have been that 60 degrees to the left. Right, since this was 90, we'd have the next one here, which we said was pi over 6 at 30 degrees, right? And then so on and so forth. So just coming back that 60 degrees on all those. And we had it labeled as 2 pi over 3 here, 7 pi over 6 there, and 5 pi over 3 for our end. Okay, just back one of those pi over 3s. Which remember 2 pi would have been 6 pi over 3s. So we just subtracted 1 off to get that. Okay. Don't forget we started then at the -4, which was both our amplitude of 4 and then our negative reflection about the x-axis. And then we went to 0, up to 4, back to 0, and then back down to -4. And connecting all of those to make my smooth consecutive cosine curve. So you can see all those changes there, but remember in reality, they shouldn't be there. The only thing that should be there is this graph right here, which is why I tried to draw the other ones lightly and even dash them to let you know that it was not my final product. Okay. If you were able to get that on your own already, awesome. You're doing really, really well. If not, then keep trying. Find all the little nuances, the things that change, and then take my words of advice in the order of the alphabet is what you should be doing these in. The A, the amplitude, the B, the period, the C, the vertical shift, and then D is our last thing for the phase or horizontal shift. All right? But we're going to continue doing more of these just for extra practice. Hopefully you will pause them and try them on your own before I go through the explanations. So make sure that you try that first, and then once you get the hang of it, go try it independently on your homework. All right, here's another one with lots of different parts to it. Again, be careful. Make sure you understand what deals with what. If you want to go ahead and pause it here and give it a try on your own, this one isn't too bad, but you should be able to get it. It's just going to take some practice to know what the 2, 3, and 4 are actually going to change from our original, in this case, cosine graph. All right, so go ahead and pause it, give it a try, please. It will help you to just struggle through it so that you actually make mistakes rather than watching me the entire time. All right, for all of you that tried it, hopefully you felt a little bit more confident with it. I'm going to go ahead and explain all of this quickly as possible so that you guys can still follow along, but we start picking up some momentum. So first thing I always like to do is when there's not parentheses around my angle, the thing following your trig function, I always like to write them in to make sure that you guys know that that is my angle measurement. They call it the argument. And so with this, we were going to be dealing with a few things going on, 3 in particular. All right, and what of those three should we trying to be find first? Remember, just do it alphabetically. So my A, which one of those things would give me my A, my amplitude? That's always going to go right in front of your trig function. So my amplitude, remember, never include the sign. It's always the absolute value of it. It's 3. Okay. Next would be the B, which affects our period. And remember, that was the next thing that was being done to the X, also with multiplying. So that was not being done to the X, so therefore affecting the Y. This is obviously affecting the X. And remember, we do the opposite for X always. So my B is obviously 4, which in turn is going to affect my period by dividing by that B, which will give me pi over 2 by canceling. And if my period is pi over 2, then that means my quarters, I would just take a fourth of 1/4 and get pi over 8. So the third and final thing that we're going to have to be trying to figure out what it's changing is that -2 on the outside. And what is that -2? Well, that would be our C value, our vertical shift. Why vertical? It's not being done to the X, so it is going to affect the Y value. And remember, Y's are Y's. We do what they say. So that is going to be a -2 vertical shift. You can even say down 2. Okay, so those are the three things in the order that we would do them in, and then we can go ahead and graph our final product. And if you're getting so good at this already, or by the end of this section of homework, then you might be able to just kind of do all of these things on one final graph and not have to do a few little ones up here or then dashed ones here. Okay, so first things first, we're dealing with cosine. So I'm going to graph all of my cosine things, but changing my amplitude first. So my amplitude will have changed to 3. Then my period, we said, would be only pi over 2. I say only because normally it goes all the way to 2 pi. We're just going to go to pi over 2. So our normal one that would go from there to there would now be squeezed in that small space. So that's what we're going to be working with. And then we're going to have to look and see what our quarters would be, which we said would be pi over 8, therefore. So I don't want to squeeze so many in right here to do that. So like I mentioned, as long as you label it correctly, I'm all good with you guys writing down 1 pi over 8, 2 pi over 8s, which would be pi over 4, 3 pi over 8, and then 4 pi over 8s, which would be pi over 2, which is what we said our ending time would be for it to repeat. And then lastly, we also said that we're going to have to do a vertical shift of -2 or down 2. And what are we going to shift down to? Well, remember, our original points would be at that 1, 0, 1, 0, and back to 1, even though they changed to 3. We're going to take every single one of those points and we're going to shift them down 2. So that means I'm going to take this and I'm going to shift down 2 to be here. I'm going to take the 0 that I would have had and I'm going to shift it down 2 to be here. So every single one of those is just going to shift. So I will start by plotting my original ones, just so that you can all see it. Would have been my 1, 0, -1, 0, and 1. And notice when I say it, I still say it with the ones, even though my amplitude changed, because I just got to label that and know that it changed. But to get the hang of this and be able to graph it quickly, I just keep saying the same things over and over, and then I'll adjust everything else after. Then I'm going to take every single one of those points and I'm going to shift them down 2. which would now put me there, 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 and there, so that I can then draw my final product, which remember it's cosine, of that. So once you get the hang of this, hopefully you'll be able to do things like that and not have to draw a couple of different things up here, which again, there's no harm in that, or have to draw a bunch of dashed versions here with all the shifts. And like I said, as long as there's no phase or horizontal shift, then it doesn't phase us at all. This is pretty easy because we're not going to be moving along our x-axis, which makes things a lot easier. Okay, so keep working at this. Hopefully you're getting the hang of it. We're on the 4th example. Let's see what the 5th one brings. So here's our 5th and final example, which I am throwing everything at you on this one. Lots of moving parts. And as you can see already right from the start, it's the form that we dislike the most. And that's when the x is not by itself. You can't tell me what's being done to the x until you get x by itself. So the very first thing I would do is, even though they've given it to me in this form, I'm going to start by rewriting it in the form that would give me the x by itself. And that would require us to divide by 3 to everything in that parentheses, my argument, the angle. But remember, that does not allow us to just divide by 3 and get rid of it completely to get the x by itself. We can't just divide to whatever we want by 3 and say it's the same. So we're still going to have 4 minus 2 times the sine of my angle. But in order to undo dividing by 3, remember we said we're going to have to multiply by 3. And that will allow us to virtually multiply by 1, that 3 over 3. And that would then leave me with, when these cancel out, the x minus pi over 3. And that then is the form that I can use to then do and answer anything and everything. And you can see there's a lot going on here. We have an amplitude, which is in front of my sine. We have a period change, which is going to affect my quarters. We have a vertical shift because it's being done to the y value, not the x. And we even have a horizontal shift. Now notice there's even one other thing that I didn't highlight, and that is this negative in front, which if I got rid of this part in front, you can see that we would have had a -2 in front of the sine, which obviously we said is going to change our amplitude, but this is also going to make a reflection across the x-axis. All my y values will be the opposite of what they normally would be. So a lot going on here. Remember, try to keep it alphabetical in order that you do these things. So first, amplitude. Second, the b, which is going to affect our period and our quarters. Then third, the c, which is going to be our vertical shift. Then I will go ahead and do the d, which would be the horizontal shift. And then don't forget, there was a 5th thing that I actually would probably do first. Okay, if there's ever a reflection, first thing a lot of people do in the morning is take a look in the mirror, right? So take care of that reflection first. So first things first, since there's so many moving parts, I'm going to go ahead and graph the original parent graph of this thing with as much of this that I can change right off the bat. So I know I can do the reflection because I'm dealing with sine. I know it starts at 0, then goes to 1, 0, -1, and 0. But because we had an amplitude of 2, we know that we can go ahead and do the reflection and that pretty easily. That would just take all of these things and reflect them about that x-axis. And instead of being at 1, we would take them up to 2. in both directions. So I would stretch all of these things to be both 2 and the opposite. All the zeros would stay the same, but when I multiply this 1 by a -2, it's going to go down to -2. When I multiply this -1 by -2, it becomes +2. So my new graph looks like this. So now I can either erase that and be dealing with that when I get to steps 2, 3, and 4, or 3, 4, and 5, however you label them. If you need to do little parts, especially when there's so many on this one, it's probably a good idea than trying to do it all at once. All right, so then the next thing that we'd be looking at would be to go ahead and find our period and quarters so that we can do some of these other shifts. Now, if you want to leave all the x's till the end, that's also a good strategy. Okay, if you want to go ahead and do the vertical shifts as well, that's fine. That would be our C. The D, remember, was our horizontal shift, also called the phase shift. And for each of those, we need to know what that was doing. Remember, this one would be positive because it's being done to the x's. We do the opposite. And then the C value was y's or y's. We listen to them do exactly what it says. So we just got to come up with a period, which we know is always going to be 2 pi for sine and cosine, but that b, which is the thing right in front there, is a 2. So those would simplify to be a period of pi, which means our quarters are again pi/4. So we'll go ahead and write those things in so that I have my whole graph set up. The only thing I'm going to have to do to finish this is the most difficult part, and that is the horizontal shift of pi/3. Okay, so once we have all this set up, we'll go ahead and finish our graph and go practice on our own. This is by far the most difficult type right here when I have all 5 different attributes that I could change from the parent graph. Okay, so starting off here, I'm going to take my original points, which were 0, pi/4, pi/2, 3 pi/4, and pi. And I'm going to put those shifts on them, which we said would be a positive pi/3. And once you do the shifting, you'll get your 5 key points. Just make sure that you've done the other parts, which were the amplitude change, the reflection, and the vertical shift, and you'll be done. As long as you have your, which in this case was the sine curve drawn correctly. All right, so doing this, you should have gotten, and then once you have those 5 key points, you will then be able to finish your drawing. Now remember, we started already up here by doing 2 things: the amplitude change of 2, and then we changed from there to there and there to there. We did the reflection about the x-axis and our zeros. So we've already taken care of the amplitude and the reflection, but now we also have taken care of our quarters and horizontal shift. We just need to make sure that we do our vertical shift of up 4. So in order to draw this with a little bit more room, I'm going to go ahead and change these. So when drawing these all down, again, a lot of moving parts, a lot of places to get confused on. The last thing we need to then do is plot our points and basically take this graph and shift that pi/3 to the right for all of these values. And then also shift up 4 for our vertical. Okay, so let's start by shifting everything up 4. So we'll take this, 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 move them all up 4. And one thing I really like to do is take my x-axis, which is what we use everything for, and I'm going to shift that up 4. So what I like to do is actually draw this in lightly, so you can kind of see it just like you always would have for your 0, 1, 0, negative 1, 0, which remember we had to stretch a distance of 2 from that for our amplitude, and then we had to do the reflections. So we moved from 0, negative 2, 0, 2, 0. So there's our curve, just like we had up here, but all shifted up 4 from the x-axis. Okay, so that is our second to last step. So I'm going to lightly dash that so that you can see those aren't part of my finished product. Because although I have my x-axis drawn incorrectly, I've done the stretching and reflecting of this thing. I also need to do the shifting of that pi over 3 to all 1, 2, 3, 4, 5 of my points, which we've already done here, which means all we got to do is label these differently. Okay, so my new 0, I would have started at, instead of pi over 4, we are going to start at pi over 3. So I'm just going to erase those, do some shifting on this, and we will be done. So now that I have those written out for my shift, remember this is 1, 2, 3, 4, 5 key points. 0 is no longer going to be there. We're just going to take these things and shift them all. That pi over 3 to the right. So I'll take these as my final product here, and I will write in my 0, negative 2, 0, positive 2, and back to that 0 of everything being shifted to the right, pi over 3, reflected about the x-axis, which we ended up moving up for, and an amplitude stretch of 2. This one in green with these as my axes would be my final product. Okay, so not easy. Some of them will actually have you work backwards and give you the graph and ask what kinds of changes were being done, either verbally written out, shifting up 4, left pi over 3, things like that, reflected about the x-axis, or they'll have you give them graphs. So hang in there. I know this is getting a little bit more challenging, but remember we're still just on sine and cosine, the easier of the functions. We'll get to tangent and cotangent next. So keep working on it. Do your best to understand all the moving parts, and you'll be better off in the end. Until next time, Alan, out.